Good evening from Slovakia. Thank you for coming to the third of the series of our lectures devoted to the fascinating phenomenon of karst and caves. This webinar is traditionally organized by Institute of Geography and the University of Pavel Jozef Šafárik in Košice and the Slovak Geographical Society. Thank you for coming to the third of the series of our lectures. I'm very happy to introduce you our guest today, Professor Luis Eduardo Paniset-Travassos. He's a geographer, doctor in geography and doctor in karstology. Currently, he's a professor at the undergraduate and graduate program in geography from the Pontifical Catholic University of Minas Gerais, visiting professor at the Federal University of Minas Gerais and University of Nova Gorica in Slovenia. During the lecture, you can ask questions using the Padlet website. I will put the link in a few seconds into the live chat. And please feel free to do it and ask some questions. After the presentation, Luz will answer as many questions as possible. At least and not last, my name is Alena Gesart, and traditionally I accompany you with these webinars. So Luis, you can start now. It's your turn now.
Okay. Just a second, then we'll share the screen. Okay. Now I believe it's fine, right?
It's very good.
Okay, so Dobry večer a děkujem za přítomnost. My Slovak language is not good, as you can see, but we can of course manage this in very good English, I believe. The idea now is to present some ways we research karst here in Brazil, especially when everything started, and then we talk a little bit about present and future. But you know that present and future, we can say that is kind of together, right? And I would like to thank you, Alena, for this invitation. It's a pleasure for me to talk to a vast audience, I believe, that enjoy karst, enjoy geography, enjoy speleology. So the idea is to make a brief comparison between karst in Slovakia, very brief, in Slovakia and Brazil, talk about the types of karst generally, some geographical distribution, past researches, like I said, present, future, and some general conclusions. So this is, I like to talk, to start with the past, not very past, but in a way past, when I'm here in this cave, when I was very young. And you can see how glad I was, and of course, how glad I am to be here talking about this subject that can fascinate us every day we research. So if we look to this map and think about all these different geographical areas, we have basically the light brown and the dark brown here. We have the dark brown relatively continuous carbonates, and then the light it's very is not continuous, and you have some other kinds of rocks in between, right? But the thing that I wanna show first is this UNESCO heritage parks, and you can see that most of the karst areas in the world we have importance for human survival of humanity, history, and so on. So if we go to a brief comparison between Slovak karst and Brazilian karst, we have mainly this kind of context that we can say that is one, it's the active, I would say, active context, active margin context, that is the European case, for example, and then we have this tectonic context of the platform that is basically here in Brazil, and the area that we have in Minas Gerais that you see, my state, that is the São Francisco Craton, that was together with the Congo Craton in Africa, for example, when we were once together. So we have some differences here. You have in Slovakia karst plateaus, high mountains. You have massive combined with folds and very structural, very, like I said, movement type of karst. And in Brazil, basically, we have a lot, but we are old as a karst system, right? So we have mainly karst developed in the Neoproterozoic carbonates. The main difference here is, like I said, the tectonic context, and of course the climatic conditions along the development of this karst. So we usually say that we live in this tropical or intertropical karst, right? So if you think about this, what the bibliography shows to us is that we have several types of karsts, mainly due to the development conditions, their main characteristics of karstification, and their geomorphological features. Tropical karst hosts the most impressive karst features, I think, on surface and underground, showing a wide variety of forms. Almost all the tropical regions, the lithological differences and context between rocks, soil cover, microbiology, and biological activity, and of course, again, climate conditions that determine the variations in the morphologies that we see, especially when we have, like I said, this vast, I would say, geological age. In the tropical karst, you can see a variety of landscapes, like I said, or features. And we have these karst towers, we have cones, we have dolines, we have stone forests, we have the Tsingy in Madagascar, and large cave systems all over the planet. One of the best known examples are the South China karst, the Madagascar karst, the Yucatan Peninsula, the Caribbean karst, and the Southeast Asian karst, right? And some of these examples that give the visibility of the tropical karst are well known by those examples. And the idea today is to show that although South America has not South America, there is not much karst, in South America, like extension of karst, but there are some important examples, of course, and Brazil is one of the biggest in South America. That's what I was trying to say. So the idea is to show this kind of tropical karst in Brazil, especially in the central Brazilian plateau, which hosts the most, the largest karst areas in the continent. So if you think about this, it's a very new paper from Marton Veres from Hungary, and he shows here many types of karst and how they develop, and we can have this table that he shows, and we can highlight basically what we have in Brazil. So we have pretty much a little bit of everything, right? We have this paleo karst, we have limestone karst, dolomite, sandstone karst, we have this karst in, like I said, in platform, covered karst. We have areas with very good examples of Karen, like these Karen fields. We have the doline karst. Sometimes we have the karst plateau, and then we have one compartment, a geomorphological compartment with this doline. So we say that doline karst and so on. So when we talk about our age, we also talk about this, the fact that we have sometimes the karst that was exposed, he was buried, and then it was exposed again. So we have all this mixture of things. And what Veres proposed in this paper is that we can have these several types of karst in the region. But if you think about these pictures here, you can see the karst in the Amazon forest that is pretty much down there. And then you can see all these details that I mentioned when you have the forest or the tropical forest sometimes covering these areas. But we also have karst in semi-desert regions here in Brazil. So in this area that was pretty much devastated by agriculture and farming, we have these areas with the denser vegetation that is connected to karst areas. And it's not coincident that we have here some irrigation equipment that probably are getting water from the karst over here. So if we make this distribution, we can see this black area here are the main speleological provinces that I mentioned, specific carbonates. And then when we take out just the carbonates and put a map with the quantity of discovered caves in Brazil, we can see that we have more than 10,000 all over the country. And we concentrated here again, showing different types, different geological groups, different ages. But what I want to talk is mainly this funny shaped state here that looks like a face, that is called Minas Gerais, that it's in rough translation, general mines. This is because we have a lot of mining activities, and the Portuguese, when came here, came to get, of course, the colony to give semi-precious stones, gold, silver, and so on. So we usually concentrate our efforts in this big area. This is the Grupo Bambuí that shows more of the caves that we know now in Brazil. These are some our regions, north, northeast, and southeast and south. And we have this number of caves. Then you can see the Minas Gerais, my states. Fortunately, we have the most caves discovered. And here again, I live right here in the edge, so it's easy for me to go to a very near area to study, or we can go as far as here, for example, that are very important casts that you will see today. So if we think about history of Caste and cave, generally we have, of course, many people know about this cradle of mankind, for example. And since that time in Africa, caves and karsts were used as shelters and places for rituals, religion, burials, and etc. Europe and around the world, usually we see traces of humans inside the caves, very deep in caves. But here we have fewer caves. Actually, we fewer cases that we see the hominids or the prehistoric people go inside the cave, very, very profound in the cave. So we have this difference between the explorers from the past, but we have, of course, the good thing is that most of the shelters and most of the caves that we have, we find some archaeological remains, very, very important archaeological remains. And then after 1500s, when the Portuguese came to Brazil, we have somehow this advance to the interior to look for resources, and many caves were being discovered, especially to use as sources of saltpeter to make gunpowder for the administration of the colony from Portugal. And by the end of the 16th century, caves explorations in Bahia and Minas Gerais started very, very, very fast. And I said Bahia, that's BA, it's Bahia, it's another state. So you see that shape state, the Minas Gerais, the face-shaped state. And then right on the north, the continuation that I show on the map, this is Bahia. So it's pretty much like people were getting above this Bambuí group and looking for caves. not just for caves, of course, but then they find caves. And then we have some records that are found in the cave entrances or in the walls or cave shelters. So we have examples from many traditions that use many different techniques, different colors, and this is mainly just the idea to show to you all. And sometimes when they don't paint the wall, they can also make some inscriptions, incisions in the cave wall. So this is one important cave. There is called Cave of the Hands, translated Caverna das Mãos, where you can see a lot of imprints of hands, human hands inside the cave. It's a sandstone cave. But the importance of this cave is that the region is preserved because all the like I said, the agriculture advanced, but they didn't destroy the vegetation that protect this cave. And this cave, when you go like 300 meters inside the cave without any lights, you can see the paintings. So this is a very rare case in Brazil where, like I said, the prehistorical man or pre-colonial man, they enter inside the cave. So you have this religious appeal that you can, Brazil is also very Catholic. There are many other religions, but mainly Catholics use these caves as a shrine or this kind of cultural use, right? And then we have this, if you think about the world, first attempt to talk about karstification or speleology, especially speleology first and then karstification, for example, is from the 16th to 18th century. And Brazil only started in 1808 because the Portuguese royal family had to flee to the colony, to Brazil, because Napoleon was making a mess in Europe, as you all know. And then from 1810, we have the opening of our ports. And this opening in 1810 helped this, what we call peak of explorations in Brazil. And these explorations, although not spellological or castological, they help to make some kind of these foundations. So these are some of the many researchers. And then I like always to remember these Spix and von Martius, two Austrian that came to Brazil with the Austrian Commission that joined on expedition of the Archduchess Leopoldina of Austria and Dom Pedro de Alcântara, that was the future emperor of Brazil. So they left Trieste on April 1817 and arrived to Brazil. They came, of course, from Rio de Janeiro. You can see this is an old map. And then if you concentrate this area here, it's pretty much the same geographical location of this karst that I mentioned, that from my state. And they make some very good registers, records by drawings, but you can see some very good similarities between this ecological, I would say, or botanical point of view, but also they try to connect like the whole landscape, and we can see some very interesting karst areas that they already started to I would say call attention to Europe, for example, and then they did all this, and all these studies start to pop up in Europe. And then we have this Peter Lund. There is a Danish researcher, naturalist, that came here and stayed very near my city. It's called Lagoa Santa, very near for Brazil. You know, it's like 60 kilometers. If you think about very near in other places, right, is like some 10 kilometers. But for Brazil, that is everything so far. So Peter Lund, he was probably the first time in Americas he put together archaeology, paleontology, speleology, everything together, because he was first interested in botanical studies, but then some disease made him turn back to the in direction, for example, of Rio de Janeiro. But he came here to Minas Gerais and started to see some um, some other Danish naturalists using, how can I say, doing some kind of fossil trafficking, for example. And he started to make the correlation between the discoveries inside caves and paleontology and so on. And he decided to stay in Minas Gerais. Richard Kron, I believe it's a German guy that came here from in the end of 19th century to the beginning of the 20th century. And by the end of the 29th century, we have a lot of influence, not that he came, but we have a lot of influence from Martel, from the French, from the point of view of speleology as a science. So here we have some examples of drawings of Andreas Brandt, that was the official, I would say, official recorder or official photo camera of Peter Lund. And you have this representation that's quite nice of these animals here. And then you have the panel nowadays. It's very well preserved. Now it's a conservation area, so it's quite nice. And then we have this very brief from 1937, the first speleological club was established in the Federal University of Ouro Preto. Ouro Preto was one time was the capital of the colony in Brazil. So it's quite important, especially this mining graduate school. So this group is very important for the beginning of or consolidation of speleology in Brazil. And then we have this in the 60s, the first speleological journal, and then 69, the Brazilian Speleological Society. By the end of the 60s and the 70s, another French influence here. You have the Pierre Martin and Guy Collet. And 59, Michel Lebré. And they started to give more, I would say, input of this speleology especially in states of São Paulo. 1960s, we have the speleo groups in Brasilia, the capital of Brazil. And in the 80s, we have this Bambuí speleo group that is here from Belo Horizonte, my city. And we would say that this consolidation of the speleology as a science, because of many of the members of this group, they were undergrads in geography, geology, biology. So they started to make their final, I would say, their final undergrad works in this area. So the karst and caves started to grow somehow in importance in Brazil. And in the 1990s, we have this advance in scientific and technical terms, because those that started undergrad, now they are in grad school and they started to make master's degree, PhD, and so on. So karst and caves started to grow. Even though we have, like you saw, I would say a recent speleological or castological history, we are making a lot of progress in both pure and applied science. That's why I'm happy in this picture, because there is no way we stay without, I would say, without research problems or work. We have many things to do, and now I will show some of these works in, like I said, in a general manner with a lot of pictures, not to make this too boring for you. So at university level, we are dedicating a lot of time in this geomorphological mapping, geoheritage sites, geotourism, environmental education, because we believe that education is fundamental. Because if people, you know, all over the world, they don't know exactly what is karst or what is a cave, or most of it. Uh, what are the importance of these areas, right? So the idea is always to make, of course, this geomorphology or geology, but also educating people in order to start to protect or understand and better live in this kind of landscape. So we have in my university now, we have this since 2010, a chair of Castology. So mainly, basically, I'm the responsible for this chair. That mainly we study Castology as a whole. So we have the both, like I said, physical and humanistic studies, because sometimes when you have people who use one cave for religious purposes, um, for I don't know, for decades or centuries, you cannot simply say that it's wrong and causes problems and that's it. No, because you need to show them ways of I don't know, making less impacts, or ways of how to protect other caves, and showing specifically to them the connection between the water they use, for example, and the caves that they are using here. So the connection between the surface and the underground. So we have developed some works and publications for this. Like I said, to it's not just popular science, is scientific papers or scientific works, scientific books, but that people can actually understand and help others, of course, to understand. Even now with this crazy pandemic, we established some rules to reopening some caves for tourism. Of course, this is always is not fixed; is always on the move, because we have a lot of new discoveries, or we have discoveries every day. So we need to be very flexible with this one. So when I mentioned Lagoa Santa, where Peter Lund came, we have one of the most beautiful examples of tropical karst over here. There is since, let me see here, since this map is from the 70s. I forgot where is the 78. This map was made by my previous advisor, Heinz Charles Kohler, and two French researchers, Coutard and Jonot, and they made for first time some very comprehensive map of this Lagoa Santa karst that we call Lagoa Santa karst. So you can quickly see how many dolines you have, the structural alignments, all these characteristics that we have from this this landscape. And the area started to grow in importance, and also in problems, because we have many of I would say small cities going to small to medium-sized cities that started to urbanize or make urbanization too fast, and then we saw a lot of, or started to see a lot of problems. So they made this limit here is the conservation unit, but we can live and do stuff, and it's not those kind of conservation units that you take people out. But then inside this conservation, this big one, we have these small ones here, and especially this big one, Sumidoro State Park, that it's a state park where people cannot, of course, live inside, but you can have tourism and other activities. So we had a master's degree that Vanya Kelly, now it's also a PhD in geography. We did this together, and with the money from the Ministry of Justice, of something like this. I don't know how to translate very well, but there is a problem, for example, with some mining company that needs to pay a fine to the government, so they must, according to law, they must give the money to the state, and then the state decided that this money should be invested in education. So this is one of the examples. So her work was accomplished, and then we did this book together. So we have mainly we decided, we decided that we have in the region mainly 10 geosites that could help people to better understand in a I would say in a easier way or a pleasant way to protect or conserve this area. So we have this Gruta da Lapinha, that is the gruta is cave. Oops. And we have this first geosites. So we have in the end you'll see we have some big how can I say this big posters explaining how it is, how it's formed, what is Karst, what is the importance of Karst. And Lapinha Cave was important because there were some research in the past for this. And I would say above now, or in the top of the Gruta da Lapinha, you have this massive that I'm showing here. And this massive was studied because on the top of the massive, we have a lot of different types of classification and a lot of types of this Karen, this lapiers or Karen. So we have this as a place of geomorphological interest or geosite. That is so important that we decided to publish this together with some friends from Slovenia in Acta Karstologica, because you can see just in one example of this massive, you can see at least 11 types of Karen that shows different stages of karstification. Another important place is the Sumidoro Cave. Sumidoro is the same of Ponor, or the place where the water goes. So this is mainly karst polia, but also as this karst polia, it's always flooded or sometimes has some periodicity of flooding. So the cave itself, the cave was visited by that Danish naturalist, and he found in the cave fossils um, of animals and humans kind of together in the same deposition and so on. So, but it's Pleistocene animals, right? So this, when he found this, it was a way of he believing that there was no catastrophic theory, because how this animal who lived, for example, 15,000, 12,000 years ago, we can have this human buried at the same place. So this cave is very important. It's seasonally flooded. The area you can see, this is the dry period. We have some very important cave paintings in this, I would say here. You can see the area where you can admire them without touching for tourism. So the scale of the area is pretty much like this. And like I said to you before, you have this, how can I say, the buried karst, and also we have covered karst, but we also have this, the covered that was discovered, that was eroded and then showed in the surface. So this is some example, aerial view. Here you have a car, like a truck, a small truck. You have here a very big, the truck. Here the ponor, the cave it's over here, and all this area here is the rock paintings. The other geosite is the top of the massive, because let's see again. It's here. It's over here. So one is here, the other one is here. So we try to integrate as much as possible the areas. So you can see the during the rainy season, dry season, and very rainy season. But now we are facing a lot of problems with the, how can I say, the distribution is not okay or not correct. So we have more of these dry periods right now. Right, you can see here the beginning of this dry, and then you have the total dry. Here is interesting to see that okay, the vegetation it's dry now, but you see the lake or the pool is still flooded. So now, because of the urban development um, in the surroundings, not so close, but in the surroundings, and mining companies and other industries, we are having a lot of water pumped from the coast. So probably you have some problems with the water level and exploitation and so on. The other place is this one. It's an old quarry that was not very well planned. So you can actually you can show students or show people how is a query without the proper regulations and so on. You can show, for example, here you can show examples of caves that were not discovered because it was inside the massif. So you have this, I would say, virgin caves. In other places, you have this cave totally filled with sediments or speleothems. So you have this Paleo Karst, like we said. We have, because of this, we can teach and we can show the different stages again of classification, and we can totally see the epikarst, how the rocks can behave together, or with the interaction of this soil and rock. And this other picture here shows some I would say some rare formations that shows how you can have this is a part of a stone forest, like we said before, the stone forest. But this stone forest was developed when the Karst was buried, covered, and then was now discovered because of the mining operations. Sometimes we see this when you have the opening of railroads, highways, and other urban infrastructure. Very near to this quarry, we have this is not on the park, but it's in the limit. The place where I'm taking the picture is the road, and the road is the limit. So in my back it's the park, and in the front is the private property. But we can stop, of course, in the road, and people can see this massive here, where you can see somehow this regression, I would say, because of the karstification process, where you can see here down the dough line, not flooded, usually not flooded because the place is a little bit higher than the water level. But you can see that you have probably this whole area here. You had the massive, and the massive is kind of retreating. It's called Baú, massive. Baú, it's that place where you put all the gold and the treasure from the pirates. I forgot the name in English, so I need to be very silly in this way. But Baú is like this box with the key. So they gave the name because of this keyhole here. People see everything, right, in Karst. The other place is the Samambaia Massif, where you can see again that areas where the Caste is uncovered and then the Karst is covered. But the most important feature, I believe, is this huge dough line over here that can have some flood yet, and of course the marks that we have during the scallops and other kinds of reliefs that show this. I would say hydrological pest, the very how can I say active hydrological pest of this area. So what we did is to make this three routes. So 1, 2, 3, integrating the geosites, and then, like I said, we made this interpretative panels or posters to the tourists to start to comprehend or better understand what they are facing or what they are looking at. So we did for the tree. We don't need to go, of course, for this, but we did for the trails. The other area that I would like to show, so one I showed to you was it was kind of here, right? So you have this Cerrado is the Brazilian Savannah. So you have this climates where you have you have wet and dry season, and then we have over here some transition between this Cerrado vegetation and then a semi-desert area that we call Caatinga. So the other park is over here. So you have around 800 kilometers from here to here. So 800 kilometers, it's not close. And then we have now, especially in this area over here, we have this national park. It's Cavernas do Peruaçu National Park. So Cavernas Cave. Peruaçu is the name of is a native Brazilian name for this big river here that comes from the area without carbonates, impermeable rocks and soil, and then goes to the karst, and then you have lots of sinks and ponors, sinks, tavels, and sources. So you have this very interesting area. So all these black dots are caves. So you can see how important it is for speleology and also, of course, castology. So the area itself, you see over here is kind of protected, kind of. And then you have here a lot of farms, you have agriculture, you have the water usage from the coast. So this is kind of problematic in the future, I believe, for this park over here. So the base level is here. It's the San Francisco River, and then you have the Peruaçu flowing to this direction. So the karst is it's quite active, I would say, still active. So this is the wet season. So you can see a lot of exposed karst, but also some areas where the karst is covered by vegetation. Very harsh environment, but then you have even harsher or harder environment when you see this. Looks like it was burned by fire, but it's normal. So you in this way is not fire. You have this the vegetation usually loses the leaves 80%, 90 to 95% of the leaves. So this is the biomass that this kind of vegetation provides to karst, for example. So it's quite nice. And when I said before the tectonic contest, you can see this picture, very horizontal or sub-horizontal, but very horizontal, totally different from other castes that probably Europe knows. This is the thing is nice because I have 180, not so small person, and then here's the scales, right? So you can see one of the characteristics of this Peruaçu river valley or river canyon, karst canyon, you name it. It's these big chambers. We have many caves with these huge spaces. So now we are now doing this. We will present this, I believe, in a couple of weeks in the International Castological School. There is a work made by Mateus, Hamilton, me, Hernando, Nicolas. We are doing this hydrological and physical chemical analyzing the hydrological and physical chemical process that leads to this, like I said, to this configuration of the karst. One of the researchers. So here we have this. The direction, like I said to you guys, was northwest to southeast, and you have this pattern vadose conduits with very rectilinear planimetry. So the area is kind of like this. You have this the impermeable rocks, you have the carbonates, and then you have some cover in this area. Some of this cover is some are sediments, others are sandstone. So it's a quite complex and interesting area. So some of examples of the region, you can see how it's so big, this area here. For example, this is the bottom of this line here. You have 50 to 60 meters maybe high, and then you can see kind of, vegetation inside, in a way, inside the cave, because this is in the middle of the Janelão cave. Janela, it's window. Janelão, it's big window. So this is the big window. Because of this, you have 4 kilometers in almost straight line following the river, the canyon, underground canyon, and then you have these windows that fall that are the collapsed lines. So you have all this ecosystem, I think, very still very well preserved. So this is another cave over here. So you can see the vast. This is here. I have this. Where is my hand here? My pointer. I believe you can see. It's around 2 meters. Just this area here, just this 2 meters. So you can imagine how big it is. So most of the caves of this region of Peruaçu River is, you can see. This is a drone footage a picture that I took with the drone, 120 meters high. So I think it's the limit I was able to. So you can see 120 meters high. It's very high, and you can see the volume of the cave with the vegetation. Like I said, now during the rainy season, it's totally different from the others you see. Many different types of Karen. You can see now very horizontal karstification, and make it simple. You can see this very old stuff. It's not, I would say, of course it's old, but old and not so active speleothemes, and some movement from neotectonic movements. But like I said, we are in a very stable area, so this is not like a big deal. But you can see how old it is in a way. So the idea, one of the ideas was to make some monitoring points in this very upstream over here in this river, and then you have this Brejal. It's a cave. So you have the Ponor, you have the cave, and you have the spring, and then you have another cave over here, and then you have the Janelão cave. You have the spring, and then goes inside again. So we started to monitor this area. You can see again, this is a person over here, so you can see how high it is, the volume of this cave. And we for the analysis of this physical chemical parameter, we use this. Of course, we got the classical ones: hydrogen ionic potential, pH. You have the conductivity, hardness, temperature. And we use these multi parameters from HANA that are very good for logging many records. So we also got these hobo loggers using every 30 minutes. We measure the water column level, the rise and the low, going up and down. And then we analyze this, putting in a graph, of course, and we see that you have a pattern, even though the river goes inside. it's still connected. It's not going inside and going to another way, because sometimes, you know, karst, when you have movements or different types of rocks or structures, is not necessarily the same river. So we have this, and we have some responses, especially in the amount of water. And the idea is to try to figure out how this water with this quantity of with this behavior or with these characteristics are helping the karstification nowadays. So let's see here. We have this, like I said, temperature. We have the pH. We have the conductivity. You see how temperature seems to be almost the same. Conductivity gets high, so you can see that the karst is being dissolved, and then you have somehow the hardness descending. So the idea is to show that these physical chemical parameters of the river, how can I say, the parameters favor the conditions for the solution or the castification. This is a very important thing in the same areas, but especially in Brejal. Brejal is here, and Lapa Brejal, and this Janelão cave here. We have studied, not me, but I'm part of the team, but Mateus and other, Nicolas and other friends are doing this, getting sediments from this, you can see, just a minute here, né? You can see the sediments all over, different types, and you know how the river works, right? So you have the sediments from the river terrace being deposited in the Janelão River. These sediments are preserving much of the records from this aggradation history of the area. And when we started to date these sands and some trunks, fossil trunks, we started to make connections with, for example, these events from the middle Holocene. So we have this bond, I believe bond 3, no, I'm sorry, bond 2, bond 3, and bond 4 that occurring during the middle Holocene. So we have this records in some caves in this area. So this, like I said, this is the present study, but it's of course the future study, because it will be nice to find this bond 1, for example. So the region is still very, 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 how can I say, I would not say pristine, but it's not very well studied, especially in this kind of research. So we have, like I said, we have this paleo floods that happen in this area. These paleo floods happen between, for example, 3.5, 3.4, 3.5 thousand years before present. So it's very, very interesting to make these correlations and see how karst can give us these answers. Just in curiosity, you see the equipment, and then you see the hardness, I would say, of the water. So you have these crusts inside outside the equipment. So if we were talking about paleoclimate or these paleo studies, for example, we have this microclimatic characterization of tourist caves. So this study is pioneering because we are from almost 3 years, 2 and something, but almost 3 years of continued monitoring of these caves. I think was, I don't remember now. No, I remember it's here, sorry. 1, 2, 3, 4, 5, 6, 7 caves are being monitored simultaneously, temperature and humidity, and we kind of want to see how these caves behave in the more arid climate, because other places in Brazil are very wet, or wet and dry seasons, and here are very, very, very dry. And we are discovering some very interesting things, and some the same, how can I say, um, the same behavior we see in other caves, that this is um, the limitation of, amplitudes, and more stable, finally, more stable conditions even in these arid areas. And you see the caves are here with this star. The other caves are inside, but then we have some, I don't remember, but we have 11, yeah, we have 11 caves that are open for tourism, and then we are monitoring 7 caves, right? So this is part of this cave environmental conditions surveillance program for this conservation unit. And we have money that is from the government and other companies that had to pay to the government stuff. So again, Karst and Karst knowledge being produced because of this. And we'll probably finish this project, by 2020. We have more than 4 million records until now, from humidity and temperature. So yeah. And I'm going to the end already. I don't know how it is our time. Almost done, I think. But this is another very interesting idea, is to make the relationship between the dry forest, that is this Mata Seca, dry forest, the karst, and the remote sensing, because you know how Brazil, like you know, and you saw in some maps over here, everything is very apart. So you need money, you need money to organize expeditions and go to the places. So if you know that here we have the global distribution of these dry tropical forests. So you can see that they are mainly in these tropical regions or tropical coast. And then you can see the temperatures is pretty much, you see, very similar to many other parts. And then when you have the coast over here, right? You have in these karst areas with the carbonates, you have this kind of vegetation. So the idea is to, you can see how the idea is to continue this identifying and mapping these dry forests connected to the karst, because you imagine walking in places like this, or like this, without knowing. For example, here, it's totally different than walking in a place like this. It's in a way easier, but you have the horns, you have thorns, you have not horns, thorns. You have all these difficulties to go, poison animals and so on. And then you have an area like this, where it's even harder to find caves or karst. So the remote sensing, if you have this spectral response from the what you see in the image and the sensor and so on, you can extract easier the places where you have this forest, and then it's easier to organize your mission or field mission to go and study, instead of going, for example, I don't know, maybe this is karst over here, or down there is karst or not, because you see it's totally different from this vegetation. But this is the dry forest in one area. So the spectral response for the remote sensing is the same if it's very green like this, or mild green, I would say. So for example, we have here like a very nice contact karst. There was this first area that we studied. You have this very like bush-like vegetation, because here is quartzite, and then we have here the karst area. This is all deforested, but then on the massifs, you have the vegetation of this dry forest. And again, like I said to you before, you have the dry forest, you have the karst, sometimes the karst is exposed, but then sometimes the karst is covered like this. So it's something like this. You see here, where should I start to look for my case, for example? So you know there are some known caves over here, and then we need to, for example, go to all these areas. So the idea was to, for example, look how it is this area here. Look how it is. It's like a normal or forest, but in the dry seasons, like I said to you before, it's very burned like. So when you do this, you can establish some very well defined data for your computer, for example, and then I can decide, okay, I will start in this area, and then I'll start in this area, and not, for example, going to the city and going here because this place looks like they have caves. No? So that's the main researches that we are doing. Of course, there are many more than this one. I need to finish, and you can see by this that the geographical locations, elements of geodiversity, environmental vulnerability, everything favors the karst studies, especially in Brazil, of course, all over the world. But here, you know, it's tropical karst, like I said, it's totally different, or it's very different from other more known karst regions. The karst system and the geoheritage have high economic, touristic, and scientific values. So that studies that we do with geoconservation together with the local communities, this always helps to preserve the karst. And of course, it preserves in one side, but also help us to produce more knowledge. Or, you know, you have this scientific I would say spaces that need to be discovered. The karst environment have been threatened by urban expansion, of course, all over the world. But here sometimes you have this boom of urbanization without control whatsoever. The lack of studies related to the connection with this dry forest and the karst system is responsible for the neglecting of this important interaction, because most of these, you can see here, most of these, for example, is the same dry forest, right? But here is the perennial river in a way, and here are some carbonates below soil cover. But for example, if you have dry forests here or here in the top of the massif, all the leaves that all the leaves that fall on the soil, they can help karstification. For example, when we have the CO2 being how can I say, being added to the water, and then the exit water will start karstification, or we improve the karstification. Identifying dry forests and the karst will help, like I said before, the researchers to better plan systematic field missions. There are many. I would put, I don't know, more 5 many here. Many research possibilities regarding development, the karst development, karst system interaction, karst dynamics, karst waters, archaeology, paleontology, paleoclimatic studies. So you imagine this bamboo group that I mentioned to you, it has roughly 22,000 square kilometers. So it's almost the size of one country in Europe of limestone. So you can imagine how many research and how many possibilities we have. So for my Slovak friends, Ďakujem, and for all the friends, thank you and obrigado.
Thank you very much, Luis. It was very interesting presentation. Also, the comparison between the Slovak and Brazilian karst. I think that you are the best Brazilian in this topic now of the Slovak karst geology and geomorphology. So
I
thank
have
you
I
very much.
had, a good professor called Alena that
Ah,
gave me
really?
a PowerPoint in the past of this one.
Thank you very much. It was very nice. During the presentation, there were a few information. Many people think that it's very nice. Congratulations on this presentation. It's very good. Our friend from Slovakia thinks that it is very nice drawing or a map of the Lagoa Santa karst.
Mhm.
So this is also like to your maps, because these maps were very different but very nice all the time, which you show us. Another questions we have from Branislav Schmida is in the Portuguese language. For me, it is very complicated, so I will try to translate from the Slovak one. What is the average temperature in the caves around Belo Horizonte? Is his question.
Okay. We have here we have one very particular, I would say, climate, that we have this rainy season that goes from sort of January to June, March, June, and then goes down. It's our winter, and our winter is around 18 degrees. Very cold, right? For Slovak, for Slovak standards, 18 to 15, uh, um, 18 to 15 degrees centigrade. So the caves, we know that behaves opposite, but the main average inside would be on the winter, maybe 20 degrees, something like this. So it would be colder outside, hotter inside. And then during the hot season, you have a mild temperature of maybe 22, maybe 23. Very mild.
Yes, in Slovakia it's around 8 to 10 degrees, so it is quite different for us. But also Branislav Schmida, during your presentation, he sent me one picture. There was a Slovak Brazilian expedition in 1997, only for information, to the
Good.
caves of Toca da Boa Vista.
Okay.
Sorry for my Portuguese. I'm not really
No
familiar
problem.
with
My
language.
Slovak is not good, so no problem.
So there were some Slovak cavers for expedition in this region in 1997. So only
Yeah.
for
You remember when I said 1990s is
Mhm.
the beginning of those guys who started to this Bambuís Paleo group,
Yes.
and Toca da Boa Vista is in Bahia, that is in the north. So usually they came here to Belo, they
Mhm.
get together with these researchers, and then they go to these big expeditions, Toca da Boa Vista, because Toca da Boa Vista at that time was being mapped, discovered, and was 100 and maybe rough numbers, 120 kilometers is the biggest from the south hemisphere. So
Okay.
at the time in 97, 96, I was entering the undergrad of geography.
Mhm. Oh, so very popular times
Popular
for
times
this.
for, yeah.
We have another question from Carol Kazarin. Sorry again for the name. Great presentation, Luis. We still have a little geological research about the caves in Brazil. From your point of view, how important or present is hypogenic processes in the Bamui Una group caves?
Mm-hmm. The Bambuí Una is near, is the, let me just think here, is northwest of Minas, and I believe I can show here, just a second. It's better for me to show the image for everybody to check. Oops. We have, it's very important, especially in this area. We don't have a lot of hypogene examples over here, but you see this, what she mentioned, it's bamboo is this one and Una is this one. So it's very mixed, bamboo, Una. It's carbonates. One will be sort of limestone, more limestone. The other one will be dolomite. And in this Una or Vazante formation, Vazante is also the name of the municipality. We have a mining company that started to mine deep, and some of the galleries reached some hypogene caves. So you started to see some hypogene features inside the cave that is quite, I would say, rare in Brazil. There is one person, Bittencourt, Christian Bittencourt. I believe if you slowly think about it, Christian Bittencourt, you will see these and many of these Klimchalk hypogene caves of the road and so on. There are some papers of this area specifically there. Okay. It's a very nice area. It's covered karst, sometimes very, very covered karst, but then you go underground and you have some hypogene caves. It's basically the only one we have, the only one that I would say, not the only one because probably a lot, but that we know. It's this Unai region and so on.
Okay, so Brazil is really a huge country with a lot of karst regions, so there is a lot of to do. So you can invite some foreign expeditions to help you.
Email me, so you have here my email. So let's do research, let's do things, because I need at least 5 lives to go to what I need to go.
Yeah, it was also my questions because Amazonia, we know it's not very accessible part of the Brazil, but you show us the karst map. There were maybe it's a dummy question, but are there no karst areas, or they are not? There's not a lot of research because of the accessibility of the region.
I joke that sometimes we are having problems in Brazil that people see a hole, see a cave, and say, "Oh, it's a karst," right? So, if we think about karst being like the classical one, being the traditional one with the carbonates, in Amazon we have mainly this one here. This is this small stripe here, right? But then if you go to speleology, you can see that you have a lot of caves all over the Amazon, right? But now is the potential of studies that we have in the iron formation, banded iron formations. So we have these ferruginous ecosystems, rocks of this mining ore that are being more researched because there are many of these iron deposits in the Amazon. Also here in my area here, we call the iron quadrangle. So you can imagine it's like a quadrangle, but full of iron. So you have a lot of mining companies, and because of the licensing processes, they need to research, and then caves in iron formations are being discovered. Okay, so carbonates, you'll be just here, for example, as for now, because like I said, it's inaccessible and it's hard. And so we have over here in Pará state, but then we have a lot of these informations. We made a book, one of that I showed. Oops, I don't remember where it is by heart, but this book over here, it's only for this ferruginous ecosystems. I would say here this spellological heritage of ferruginous rocks. So this is the first book in Brazil. It was, I don't remember when it's new. I don't remember now, but it's the only one that we have that is kind of a reference for this kind of caves that some people call karst. Okay, but I would have my reservations to say karst. But I'm being okay and saying, for example, a paleo karst, because there is no doubt you have some huge caves in iron in Amazon, but you have very small ones over here. and something happened, for example, between the iron formation here that was on the top and here you have another rock, and this rock was removed by solution. So this is not it's not possible to negate this, but then you compare to the traditional karst, I think it's too much. But you know, like I said, paleo karst maybe.
Okay, so that's very interesting. Thank you very much for
Very
the
nice.
answer. I'm only going to check if there is another question. No, there is no question. For me personally, it's quite a new topic, this connection between the karst areas and the dry forest, because you are searching for caves by this sort of the research in Slovakia. We are searching for caves mainly in winter when the snow cover is
The blow holes.
or the yes. So this is very interesting for me. I hope I will hear something from you in next weeks about this topic also, because we will meet us on the two conferences in June together.
Yes.
So we will see. Thank you very much once more. If you want to tell us something more, you can do it now.
No, it's just thank you very much all for the attendance. I hope it was clear enough to everybody. And I joke, but it's not a joke. Please email me if you have any questions, and we can always have a room for partnerships and so on. Life is too
Okay.
short.
I think I will write you an email or something similar. Thank you very much once more, Luis. At the end, I would do some small advertisement for the next presentation, which will be at the end of the June. My colleague and friend Branislav Šmida, who sent you a few questions now, in the Slovak language, we'll talk about the research of caves in Venezuela steppes.
The
Where,
tapuis, yeah.
because they were there on a few expeditions and found very interesting long caves. So he will do the presentation, unfortunately in the Slovak language, but I'm sure with beautiful pictures. So you are also invited for sure. So Branislav is a caver, spellologist, geologist, and biospellologist. So it will be from this point of view. For sure,
Super.
very interesting. So everyone is welcome. The information will be sent out in a few days, for sure.
Great.
So thank you very much once more. I wish you a nice evening, and I'm looking after to see you on another webinar in a few weeks.
Thank you very much.